Hello all, as a continuation of my lecture series in special electrical machines, now we are going to discuss about a case study on electrical machines. So the case study is related to troubleshooting induction motor shaft issues. So we people learn about stator, rotor, shaft and how to connect the motor with the application. So this case study is about Luby Industries, which is a company which manufactures induction motors. So in this video, we are going to discuss about the situation, what happened, what was the observation by the engineer in the company, and what was the findings and what was the solution given to the customer along with the remarks. So the motor which was bought by a company called company for the process of groundnut processing factory at Gujarat. So they purchased a motor model of 40 HP 6-pole F-class 3-phase induction motor for the purpose of groundnut processing, which was bought from the Luby Industries company. So first, what was the situation happened is the motor shaft broke for after running for a short period of time. So the client contacted the company and said that that was a new motor, but that was shaft had got broke for running after running a short period of time. And the motor which they bought is F-class induction motor. So this F-class, I will explain you what is the F-class. So this is the nameplate of that particular machine. So that class is that is nothing but the insulation class, where we have from class A, B, F, H, N, R and S. So this is based on the temperature, minimum operating temperature and temperature rise limit. So what are the applications that class A machine is used is mentioned in this table. So if it is class A machine, then the maximum operating temperature would be 105 degrees and the temperature rise limit is 60 degrees Celsius. Typical applications is older motors, low power application appliances and transformers. If the insulation class is B, then the maximum operating temperature is 130 and the temperature rise limit is 80. Temperature rise limit is 80 and standard industrial motors, pumps and small generators are the applications. So if it is class F, then the maximum operating temperature is 155 and temperature rise limit is 105. And these motors are used in HVAC systems, high performance equipments. If it is class H, then the maximum limit is 180, rise time is 125 degrees and high power motors, traction motors and heavy duty industrial use. So similar way, class N and class R with 200 and 220 degrees Celsius respectively, and these are used in aerospace applications for class N, and class R is used in military grade equipments. Coming to class S, it is 240 degrees. It is used in extreme temperature environments and advanced applications. So similar way, this company is manufactured class F motor, which is induction motor, and that was bought by the groundnut processing factory. So what was the observation is, the foundation of F-class induction motor should be solid and stable to ensure proper installation and operation. So the foundation should be solid and stable. So it should be constructed using a concrete base designed to withstand the motor's weight and vibrations. An adequate reinforcement and leveling should be implemented to maintain the motor's alignment and prevent any movement or misalignment during the operation. So what the engineer, so what was observation is, the belt drive system should be properly tensioned, maintaining the manufacturer's recommended tension levels to ensure efficient power transmission and avoid excessive wear on the belt and pulley surfaces. So what was the finding is, while inspecting the foundation of the motor, the engineer found that the surface was uneven and unbalanced. So the first condition what was that is it should be a concrete base, but this was not followed in that particular manufacturing process. The motor had inadequate support and the materials used for the base support were of substandard quality. So while checking the speed of the machine, he observed that it exceeded the RPM recommended by the manufacturer. So these are all the findings made by the engineer from the industry. So what was the solution given is, the base should be proper. So engineer visited and approved instrumental in identifying multiple factors contributing to the motor's failure and damage. So engineer recommended the following measures. So first, they have to construct a well leveled foundation for the motor. So secondly, they have advised to have heavy C-section channels as a robust base plate or support for the machine. So next, he recommended them to replace the pulley and the belt as they had both worn out. So finally, he suggested them to buy a new pulley of appropriate size to ensure the proper with the manufacturer's recommended RPM range. So this was the solution given. So what was the remarks is, to ensure that the belt and the pulley are properly fitted and that the tension is appropriate before starting the motor, and the base should be proper. So this was the issues detected. So this was the particular reason why that particular motor had an issue. Thank you.